everyone, in this video we will go over some code in Python to do the text processing. First of all, I would like to say that we are using a very small corpus so we can see the difference between applying a function and having the function working. So in real life, we have much larger corpus and we usually don't check every single line of the comments or of our text to see if it worked or not. So that's why we're gonna check here in this small corpus first. So we know that this function works for what we want it to work. So first, our corpus here is very small and contains everything that we learned that we have to remove or convert. So here we have HTML tags, special characters, emoticons, contractions, emails. We have links, we have a bunch of white space, we have mentions, numbers, punctuation signs, and mix of lowercase and uppercase text. So here we can see the text. We have here HTML tags, title, hi, I'm happy to be here, anti-dot, this is my email, blah, blah, blah. The link for this class is at this. Students, instructors can log in, 45 days starting now. Let's do this. We're moving fast, but we have to finish this. Do not forget, this is a simple code. Real life is a little bit more trickier. Okay, we're gonna start this code by removing the URL. I would like to say that you don't have to follow this exactly steps, or you don't have to follow those functions, but you can see that there are many other ways of doing the same thing. But this one is just to exemplify what we saw in the theory part, like why we have to remove and how we remove it. So we will use the simplest ones here that usually are very effective. But if you've seen somewhere else that they use a different function to do the exactly same thing, that's normal. There are many ways of achieving the same result. So let's get started. We're gonna remove URL in the simplest way, and you guys will see that we use regular expressions a lot. Those are the simplest one, and they are very useful. So check the documentation. I put it here, the link, so you can go ahead and check. They have different ways and different functions that we can use, and they help a lot. So this will remove everything after the HTTP. So we're going to import regular expressions. If you don't have, please install using pip. And here we're going to use the variable corpus where we stored our text. We're going to use the substitution function of the regular expressions. So we're going to remove everything that comes after the HTTP. So this is the expression we use when we want to remove everything after. This as plus means that we're going to remove everything after. And this is if you want to substitute for something else. Let's say that I would like to substitute this for the word site. I would put it here. But in our case, we just want to remove, so we'll leave it blank. And where are we going to apply this? Corpus. So we're going to apply in our variable that has our text. You can see here that I'm changing the corpus every time because I don't need to create another variable to have the exactly same text that I'm cleaning. If you want, you can always create a new one and save your original corpus if you want in another variable. So here we can see that the HTTP, everything is not here anymore. Also, we have now how to remove the HTML tags. We can use regular expressions or beautiful soup. Since we use regular expressions over here, I will use beautiful soup right here. And to use Beautiful Soup, you're gonna have to have a BS4. So if you don't have installed, this package is you just have to download using pip. So from BS4, import Beautiful Soup. Beautiful Soup is used for that. Like we're gonna remove all the HTML tags. We're gonna call Beautiful Soup in our corpus, and we're gonna pass LXML. That is for all the HTML tags. And here we can see that it removed all the HTML tags that we had here, and now we only have the title, that is the title. Next, we're gonna remove mentions and emails. The simplest way is using regular expressions, and it will remove everything that has at in the word. If for some reason you don't want to remove something that has at in the word, it's not our case, because in our case we want to remove everything. You should not use the regular expressions, but in our case we want to remove everything, so we're gonna use regular expressions. Again, substitution, we're gonna put here our expression that says everything before the at and everything after the at. So everything that has an at on it, every word that has it, every part of the text will be removed. So we can see here that not only my email is not here anymore, but also the ad for the mentions for students and instructors. Now we're gonna remove simple emojis. Some of specific emojis, because we have like Android systems, iOS, and others, sometimes they will not be everywhere, like they will not be in this package specifically, and you're gonna have to download a package to specifically change the emojis in your data set. But in this one we only have an emoticon, so this one will work. Usually this Unicode, those are all the codes that we have here. They are usually the ones that we have in our text data, but it can appear others. So here we're gonna have this package. If you don't have it, you just download using pip, and we're gonna compile all the emoji patterns that we have, like emoticons, symbols, and pictographs, transport and map symbols, and blah blah blah. So we're gonna use that, and then we're gonna define a function to remove the emoticons. So emoticon pattern, that this guy that we had here, we're gonna compile everything, and we're gonna substitute for in anything that has in our corpus, we're gonna substitute for this. So here we're gonna call the function in our corpus to remove the emoticons. And here we can see that we don't have the emoticon anymore. Now I'm happy to be here, but without the smiley face. And check it out that it's still here, the parentheses. So it will only remove the patterns of emoticons and emojis, and not the other symbols. So after that, we can remove any duplicate space. This does not remove the space between words. It will only remove like for this one, for example, because it has more than one white space. So first we join everything, so all the text will be just one big chunk, and then we're gonna split the text again, and we're gonna leave just one space between each word. Okay, now we're gonna remove the special characters. In this particular corpus, the special character is the accent mark in the word anti-dot. So we're gonna import the string, we're gonna import Unicode data, and we're gonna define a function to remove. So we will pass the corpus, right? In this case, we're gonna call X. We're gonna normalize, encode, and decode. And that way, everything will return the corpus without the special characters. Here we can see that we have still the word, but without the special character. And that's important, and that's why we have to use this specific function. Otherwise, it would remove everything with the word. So we don't want that. We just want to substitute the special character that is in our word for the word plain. Next, we're going to remove numbers using regular expressions, but you can also use regular expressions to substitute the numbers to words. In our case, we usually don't substitute because we don't really need the numbers. So we just remove them to get a more clean text and use without the numbers. We don't need the numbers. So here we're going to use this regular expression, that says that the numbers should be removed. And here we can see that the 45 days here, we don't have it anymore. Now we have lowercase conversion, and that's the simplest one, that's the easiest one, and that's the one that we should never forget. So this one, we have the corpus and we have the corpus.lower. When we did this, we use all the string will be in lowercase. Okay? Now we have everything in lowercase right here. Next, we're going to expand contractions using contractions package. The good thing about Python is that people develop many different packages. So if you run through something that you don't know, or you have no idea how to change or how to remove, usually they will have a package that will help you, and that makes things much easier than in other languages. So here we have import contractions. If you don't have that package, you probably don't, just use pip install and install that package. We're gonna define a function to replace the contractions in a text, and we're gonna return the contractions .fix in that text. So because those contractions are inside that package, so the packager will do all the work. We just define this function in case we need to do more than one case. Here we're gonna use corpus, replace contraction in our corpus. And now we know that I'm happy is now I am happy to be here. And something else that we had, let's do this, it's now let us do this. One thing that I just noticed is because here we have back the I in uppercase. In our case, it won't be a problem because we're gonna take it out the stop words, and we'll be able to do with the I in uppercase. But usually you're gonna have to apply it again, or just let you apply this corpus lower later. But sometimes if you apply the corpus.lower later, you won't be able to use this contraction package. So the best thing to do is use before and after. It's super simple and does not take a lot of computational time, so it's easy to use before and after. Now we can remove the punctuation signs. Why we couldn't remove it before? Because the contractions have a punctuation sign, and if we remove before, we would not be able to expand the contraction. We would have missed the I am, the let's do this, because this would be all together and we would not be able to expand the contractions. So now we can remove all the punctuation signs, and again we're gonna use regular expressions. We're gonna substitute all the symbols, that's the expression to remove all the punctuation signs. And you must be thinking, how do I know all that? How do I know the function? How do I know the expression that I have to use? If you check the documentation of the regular expressions, you will see that they tell you everything. Like you will be able to see, oh, you just have to remove something in the middle of a word. They will let you know how you form your expression, your function, to be able to remove that specific case. So this one is for all the punctuation signs. And we can see here that we removed everything, like the parentheses, the comma, the punctuation signs, everything. So here we will tokenize a little bit before, and we're gonna do it again later, just because we're gonna use one package of from Python to remove the stop words, and usually they need to be tokenized, so it's easier to parse through. But if you create your own package, like your own set of words, you just have like to create a list of words that you want to use as stop words, and you just parse through this list. So you don't have to remove, tokenize, or do anything else. But in this case, we're gonna tokenize. Tokenize is one of very important techniques that we use in text processing, because in that way we will transform the whole text into words. In our specific case, when we have a comment, our comment will be one line in our data frame, and we're gonna have in that line every single word separate after we do the tokenize. Also, in this case, we're gonna use the tokenize to tokenize into words, but you can do for sentences and paragraphs as well. If you have like a book, for example, and you want to divide that word, like that text, into sentences, you can do that using a different tokenizer. Okay, so the tokenizer will be done in this stage, so we can use spaCy to remove the stop words. It's not a rule to do the tokenization in this stage. It's not a rule to use space as stop words vocabulary. Usually we'll have to create our own set of stop words to adapt to our data set, as I said before. Tokenizer uses the natural language toolkit, and that is a very, very important toolkit that we're gonna use a lot. That package, NLTK, we'll use throughout the course. So the documentation is here, and I really advise you to go over and see what they have there. So we're gonna import this package. If you don't have that package, again, pip install. From the package, we're gonna import, from the package tokenize, we're gonna import the regex tokenizer. That means that we're gonna use some regular expression as well. It just use inside the tokenizer a regular expression, and that means that we're gonna parse and we're gonna subdivide into words and not into sentences, not in paragraphs, and just words. And also here we say that we only want the words. In case you forgot to take it out the punctuation or something, you will make sure that you only tokenize the words. Here, just for educational purpose, we're gonna save the tokens in a different variable. Like we have been using corpus all the way through, but now we're gonna use tokens for the tokens. So here we can see what it does. Like we have a big text, and we now have all the words. And that's very important because that's what we want to create the word embedding. So the vector can only be created for the tokens. Of course, if you have a big token for a sentence, you can have a vector for a sentence. That's not a problem, but usually the vectors for sentences are not that accurate as the vectors for words. And here we have the stop words, and we're gonna use spaCy. But like I said in the theoretical part, we have many packages in Python that have stop words. And we also can create ours, creating a list, a dictionary, different methods to create our own. So we're going to import spacey, and from spacey, we're going to import stop words. Those are English stop words, but they have from other languages as well. Like they have for Spanish and others. So we're gonna create another one, like tokens underscore s join for T for T in tokens, if T not in stop words. So we're gonna parse through the document, and each token they're gonna check, and if the token is in the stop words, we won't be able, it will not come back to this token underscore s. If it is, it will be removed. If it is not, it will continue in our text. I will add here just for us to see what are the stop words. So here we have the stop words of this specific package, the spacey one. So here we know like words like another are considered stop words, more are considered stop words. So here we had more, we don't have it anymore. And like I said before, it didn't check for the Y here because the Y is in uppercase, and in this case, this stop words have Y, but it's in lowercase. So if we wanted to do that, we would have to come back here, and after the replace contractions here, we should just do corpus equals corpus dot lower, and we would have them again lower. Okay, and then let me just run this over again so we can have the token here in lowercase, and right here we would not have the Y. So those are the stop words in this specific package. Like I said, you can create your own. Those are the most common words, and usually they will take it out. People will usually use packages that are already there, but like I explained in the theory part, sometimes we will remove words that are important to us, so we can create our own set of stop words, and that's not a problem. Next, we're gonna use the lemmatizer, so the lemmatization, to bring the words into its root form. So again, we're gonna use the natural language toolkit, and we're gonna import the WordNet lemmatizer, and from the corpus we're gonna use WordNet. So we're gonna call the WordNet lemmatizer in this lemmatizer. This is a variable that I put this name, but you can use another. And it's important to use a map like the one in the next line, so all the words will be converted to its root. Otherwise, as a standard, only nouns will be converted. So here we map nouns to N, V to verb, J to adjectives, R to adverbs. So here we're gonna cover all the types of words, and they all will be a lemmatizer, like they will all be transformed to its root. So here we're gonna define one function to go over all the text. So the text will receive after a post tagged text, because first we're gonna tag every single word as what they are. Like if the word each is a noun, we're gonna use as a noun. Keep is a verb, we're gonna tag as a verb. So here first we tag, and then we lemmatize them. So let's say here we had moving fast, and now we have move. So this is what this lemmatizer does. And if you see here, they used all the words that were in the token, but it didn't need to be a token. the text is already together. But if you need a token after all that, you have to tokenize again. And that's also easy and not computationally expensive. So you can just go ahead and run the tokens again. And in this case, we're gonna have a different one because let me run this guy again. And then here, so we can have the tokens S. Tokens, okay. Here we are tokenizing the corpus, but we can tokenize the tokens as, so we can see this small text, what it is. Oops. So here we have to print again. So instead of all the other words that we had here before our stop words, and before we even had a more like a larger text in the beginning, we now only have those words. So those are the ones that are important to us. Those are the ones that we're gonna use to produce a vector, and that is how we're gonna have the words in our data set after we process. So each line will receive the tokens like this. This part is a little bit extensive, and we know that we need some time always when we are doing text processing, because this is a simple example, and in real life sometimes our texts come with many more noisy data and we have to spend a longer time doing this part. So keep that in mind, and I see you in the next video. Bye-bye. If you have any questions, just let me know. Bye.